Bismillahir-Rahmanir-Rahim. So we are interested to discuss events in probability theory. So an event is a set of outcomes of an experiment, right? So event an event is a set of outcomes of an experiment, right? It's not set of all outcomes. So it's only a set of outcomes of an experiment. So an event is a set which is a subset of a sample space of the experiment, right? So in other words, an event is a set which is a subset of the sample space of a probability experiment, right? So let's illustrate this with the help of some examples. Let's consider an experiment to roll a six-sided die, right? Roll a six-sided die. So, and we are interested in the number of dots on the side facing upwards. So observe the side facing upwards, the number of dots basically in the sides of so the sample space is either 1 or 2 or 3, 4, 5 and 6. So there are 6 likely outcomes. So this is the sample space of this experiment. So each subset of this sample space is an event of this experiment. So each subset of this sample space S is an event, right? So it is and the events of our interest may be only a few of all those possible events, right? So for example, we can be interested whether the die rolls 4 or higher. So this can be a possible event. E1 roll 4 or higher. So this is descriptive, and we can write it like this: 4 or higher is 5 and 6. So this is an event. So this is a set which is a subset of this sample space, right? Or another possible event is E2, for example, roll an even number. Roll an even number, right? So this could be 2 or 4 or 6, right? So these are the possible event. A few of the two of the many possible events. Another event can be, for example, roll is a square of an integer. Roll is square of an integer. So you see, of all these numbers, only 1 and 4 can be square. 1 is a square of 1 and 4 is a square of 2, right? So the E3 is either 1 or 4. So 3 possible events of the many possible events. So another example, uh, example of an event, probability event. Uh, for example, wait for someone to make a phone call and observe the duration of the call in minutes. Observe the duration of a phone call in minutes. Right, so the sample space is x number of minutes where x is greater than or equal to 0 and x is an element of set of real numbers, right? So there are many events possible. For example, one of the possible events could be a call which is lasts more than 5 minutes. The phone call lasting longer than 5 minutes. So it can be described like this. It is an x while x is greater than 5, right? And x is set of element of real number. So this is another example of an event, right? So let us describe another example. For example, generate 3 random bits. Generate 3 random bits, right? So the bits can be of any of the possible patterns. For example, 0 0 0, it could be 0 0 1, right? Then 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So these are 8 possible outcomes, right? So this is the sample space, and one possible event, for example, denoted by E1, for example, bits with the bit pattern, bit pattern with 2 ones in them, right? So this will include this one, this bit 0 1 1, 1 0 1, or 1 1 0, or 1 not 1 1 1, right? Because exactly 2 bits, right? So this will be 0 1 1, 1 0 1 and 1 1 0, right? So this is a possible event. So another possible event could be bits with 2 or more, bit pattern with 2 or more ones, E2. Bit pattern with 2 or more ones in them, right? So this event will include all these bits, all these bit patterns, 0 1 1, 1 0 1, 1 1 0, and this one also now, 1 1 1, right? So these two events are different. Bit pattern with 2 ones, with exactly 2 ones, right? Exactly is implied. So 0 1 1 and 1 0 1 and 1 1 0 only. And bit pattern with 2 or more ones, so this will be then 0 1 1, 1 0 1, 1 1 0 and 1 1 1. So these are a few 3 examples of events in probability theory, right? And in this case here in example 1 and example 3, the sample spaces are discrete, and the event comprises of a set of discrete numbers, while in this case example 2, the sample space is continuous and the event is over a continuous interval, right? So there are a few points that we can note about the events. For example, uh, if the event consists of a single outcome, right, it is called an elementary event. Elementary event. Uh, for example, the event consisting of a single point is called an elementary event, right? And also note that phi is a subset of sample space, and S is itself, a set is a subset of itself, right? So sample space is a subset of S also, right? So phi and S are events. Phi and S are events. So phi, which is an empty set, is said to be an impossible event, is an impossible event, right? Or null event. And the sample space S is called the certain or sure event, is certain or sure event. To further explain, so if we, for example, see this experiment that we roll a 6-sided die, so the possible outcomes are 1, 2, 3, 4, 5, and 6. So if we say that none of these numbers appear on the upward side, so this is an impossible event, right? And the sure event, for example, we say that number is any one of 1, 2, 3, 4, 5, or 6. So this is going to be a sure event. So number is going to be any one of these sample points, right? So phi is an impossible event or null event, and S is a certain or sure event. So this was point number 1, this was point number 2, and another point related to the events is that the event A union B, if there are two events A and B, and if we consider the union of events A and B, then it is the event that occurs is an event that occurs if and only if, right? If and only if A occurs, or is important here, or B occurs, or both. So if event A occurs, or B occurs, or both occur, so then we can say this is a union of these events, right? A union B. Likewise, the intersection of events A and B, if there is an event A and there is an event B, and if we consider their intersection A intersection B, then it is an event. The intersection is also event, right? The intersection of events is an event. The union of events is an event. Is an event that occurs if and only if A occurs and B occurs. Right? So A intersection B is an event when both A and B occur, right? Similarly, the complement of an event A complement C is the event that occurs if A does not occur, right? So the complement of event A is another event which occurs if A does not occur, right? So when we find that A has not occurred, so we can say that A complement of A has occurred, right? Similarly, so two events A and B, are called mutually exclusive if they are disjoint, right? So events A and B are called mutually exclusive if they are disjoint. That is, the intersection of A and B is a null set, right? In other words, A and B cannot occur simultaneously. In other words, A and B do not occur simultaneously. Right? So this is the mutual exclusion of two events. What about more than two events? So three or more events. Three or more events are mutually exclusive if every two of them, if every two of them are mutually exclusive. So this is all about events, and we can relate basically the outcome, event, and sample space in probability theory to universal set, element, and set in algebra, right? So for example, let me write it down here: probability and set algebra. So the sample space in probability theory corresponds to universal set in set algebra, right? An outcome of the sample space is an element. An outcome of an experiment is an element of the sample space, right? So similarly, so this can be an element of the universal set. So event in probability theory is a subset of sample space. So similarly, any subset of this universal set corresponds to an event in probability theory. So this finishes our discourse and discussion on events in probability theory.